Today we're here with a 2009 Mercedes 204 model. This is the E180 compressor, and the customer complaint is it's a no start. I was here yesterday and I did some preliminary work, but as I've always said on my channel, I hate working on Mercedes because of the way the data is laid out. It takes me so long to sift through Mercedes service information than to do the actual diagnosis. So I came yesterday, did a few things, tried to look at the data, wasn't getting much anywhere, decided to go home and look at the data in a more relaxed atmosphere, and now we're here to proceed. So the first thing is, let's see what this thing is doing. So this guy came to Temple, I'm in Parklands area, and he drove here fine. When he went to start the car after the service, no start. He went home and got the second key, and it's a no start. They tried checking a few fuses. I can see here he tried doing something here with the shifter because it was open, and nothing doing. So that's where I am. Luckily for me, this hasn't been fooled around with. The car is in good condition. Rarely do I get cars that haven't been touched. I'm usually the last resort. So let's try the first key, see what it's doing. So you see the dash comes on, but nothing happens when you crank it. Move that key, and I'll wait for the dash to die down and put in the second key. Alright, the dash is dead. Let's put in our second key. Again, the dash comes alive. Try and start, nothing. And the dash doesn't even come key on. But one thing I did notice is our radio. We're able to put it on. So the radio does come on, and when you remove the key, the radio should go off. I've not tried that. Let's try that. So here's the key. Let me just remove it. Yep. So that is kind of a sign that the keys are being recognized. So since both keys are doing the same thing, we're going to put one aside. We're only going to deal with this one. And the first thing I try to do is to find out the information. Mercedes cars are heavily computerized. Everything is done over CAN network. I needed to know who authorizes who to get the ignition feed. I didn't get much information from WIS. I had to go digging online to see where to start. And what I found out is this. From WIS, I found that, okay, before I go to WIS, I wanted to describe what I found out by doing some research. Mercedes have got three primary circuits. There is a terminal 30, then there's a terminal 30G, then there's a terminal 15. And there's a fourth terminal circuit, which is terminal 50. So terminal 30 is permanent battery power. That's what now I got from WIS. 30G is also a battery power feed, but it goes through a relay. So that suggests to me that it is a timed permanent power. So it goes off when the car goes to sleep. And I did test here yesterday. I found out that terminal 30G, immediately you open the car by putting on the key fob or by opening the doors, 30G comes alive and stays alive throughout the duration of the car until the car goes to sleep. So 30 is permanent battery power, on all the time. 30G is on when the car senses some activity and goes off when the car goes to sleep. Then there's terminal 15. Terminal 15 is actually ignition key on. Then there's terminal 15R, which is ignition key in the run position. So 15 is more like accessory, 15R is more like key on, and then terminal 50 is the start signal. That's what I found out outside of WIS. They did not put that information in WIS, believe it or not. Then now I wanted to find out who wakes up the terminals. Is it the ignition switch or is it something else? So that's where WIS comes in. So let's go to WIS and we look at that information. All right, here I am in WIS. And the first thing I want to do is to go to the table. Oh, before I do that, I want to show you something pretty cool. At least I found it cool. If you look here in the data sheet, the data card for this car, look at this. 16627L designated as Kenya. This car has actually been designed specifically for our country. I've never seen that before. I found that pretty cool. I've always seen other designations, but not specifically to this country, which means this car was bought from the showroom here. Okay, first I want to go to the table of contents. In the table of contents, we're going to go to basic knowledge. I want to go to functions. We come here, passenger cars, model. We go to model 204. And then here, overall network, GV and function description, table of contents. So let's get in here. Overview of systems, or let's go to the network function. Okay. Now, WIS really need to do a good job of putting graphics in their model. These are such low resolution graphics. I mean, for a database as expensive as this is kind of crappy. Shouldn't be the case. So what I want to see is my ignition switch. So let me go to ignition. Search for ignition. Here, electronic ignition switch control unit is N73. Okay. Now, I will go down and here we have the description for CAN, most, etc. I know what all these are. So let me go down. Overview of system components for overall network. And then we're going to go to the ignition switch. What I want is my component description. So let me find ignition again. Yeah, when I tell you this data is badly laid out, I'm not kidding. Imagine you coming to a diagnosis and doing this. You're going to fight with the data instead of diagnosing the car. So let me go to my component description for ignition control module. So here it is, electronic ignition switch control unit. The location, of course, you know where the location is. But what I'm interested in is this right here. And this was key for me coming now to complete my diagnosis today. Controlling functions. The electronic ignition lock control unit controls the following functions: central locking, convenience feature, drive authorization system stage 3, that's DAS, shift lock function with transmission 722, which we have, encrypted data exchange according to hash method for key identification, and then here, this is what I needed: rotation angle dependent activation of individual circuits, circuit 15C, 15R, 15, 15X, and circuit 50. So my ignition control module is the one that is responsible for enabling circuit 15 and 15R, which we don't have in this car. 15 and 15R are completely off. So now that I know this, I want to come to the scanner. We're going to plug in our scanner, and I will not use this scanner. I'm going to actually use Sentry. And I know we look like we are dead, but since the doors are open, module's actually alive. I know my instrument cluster is on, it's on standby mode. That's why it's like that. And I know there's power, supposed to be power to this. So let me hook up a scanner. It will not self-identify. I need to put in exactly what vehicle I am in. And then I'm going to do a whole system scan. And I want to see what comes on. I should expect at least to see this, the instrument panel, the front SAM, and the rear SAM. Those are the ones that I'm interested in for now. Let's go to Sentry and scan this car. I tried scanning this with Sentry. It could not scan. I found out that Sentry does not like it at all. When your ignition key is not on, it keeps hanging. So we are back to our ThinkDiag. I keep just pulling and pushing it back in to keep that cluster awake, because I want that cluster not to go on standby. It's going to take a very long time to read because we are basically half dead. It's pinging the modules and waiting for a response. So I have to be very patient, but I need to have all the data that I can have. So let me just wait for this to all finish, and then we'll proceed. Okay, we're almost done scanning, and boy, that really took quite some time. Just want to catch this right now. When it's done, 14 minutes, and that's what we have. So let us see quickly what we have here. We actually have the engine control module online. Interesting. We have the rear SAM. We have the driver SAM. Instrument cluster. And I did not see... Oh, the ignition lock is here. Electronic ignition lock. All right. So let's go to our electronic ignition lock, N73. I can't switch on the ignition. I'll just say okay. It will communicate regardless. So we have no faults, but what I'm interested is in the status of the circuits. So we've got all these. So select all. Okay. So the first thing I want to do is to take out the key. And then I'm going to try and operate any of these buttons here. All right, we've got no changes. So I'm going to put the key inside. All right, so we got circuit 15C goes on and off. So we have our terminal 15C. Now let's see whether we have our terminal 15, the main one. That's the first one. Okay, we do not have terminal 15, 15R. We do not have 15R. And we obviously will not have terminal 50. So we only have 15C. Now, interesting, look at the last data pit, last two, transmitter key in position 15. 15R is active and 15 is active, but we have no terminal 15 circuit. So is this a problem with the terminal 15 in the front SAM or not? I'm just gathering data at this point. Now, take the key out. Oh, let me leave the key in. I don't want to lose my data. Let me go back out. Now, what I want to do is to go to my power supply. And we have power to the ignition switch. My battery is getting weak. I need to put a charger on it. Oh, let me go to drive authorization. Okay. Drive authorization, we can now look if our keys are detected. So look at this. I've taken the key out of the ignition. No valid key detected. Put it in. Valid key was detected. It says yes. So now that we have key detection, we know that we can eliminate our key as a problem. And I kind of suspected that simply because this thing wakes up the dash when you put it in. So I wasn't worried about the key. Let's check the second key. So here's the second key. I'm going to put it in. And it says valid key detected. So both our keys are good. So we're going to maintain just this one key. We have no issue with that. And this also tells me that this ignition key has a valid communication network because I am communicating with it right now. And if I was not communicating with it, there's no way I could pull all this data from it. So where are we? We have a valid key that's detected, but we do not have our terminal 15 turning on. The reason why we don't have our terminal 15 turning on is because the key is being recognized to turn on terminal 15 when we turn it on, but it is declining to turn on terminal 15. Why is that? Either we have a problem with terminal 15 in the SAM, or we have an issue with this steering lock. The steering lock, if it doesn't initialize, cannot turn on terminal 15, cannot allow terminal 15 to be turned on. Now, I've noticed another thing. Listen to this. I'm not hearing the lock engage. So is there a problem with the communication between here and the lock? I don't know. For now, let's do things one by one. Let's go to the front SAM and see whether we can manually turn on terminal 15. So let's exit out of here. Okay. Driver side SAM. That's where terminal 15 is turned on and off. And first, let's read fault code. No fault code in that SAM. This car is behaving normal right now. It's very strange. Okay, let's read the data stream. Status of circuits. Let's see if we have anything. So right now we are off. Voltage at circuit 30 and 30G is on. This is important. Circuit 30 is our power supply, permanent power supply from the battery, so that's good. 30G is our power supply that runs through a relay, so that is good. Actuation test. Voltages, very good. So we can turn on the relays individually. So let's go to circuit 15 relay. You're supposed to have the ignition switch off, which we do have. It's off. Okay. Right now it is off. F3 will turn it on. So let's press F3. I heard the relay. I'm not seeing anything different in the car. Okay, I know some fuses for terminal 15, so let's go put a test light on one of the fuses and we'll turn it on here and see what happens. So that's one of the fuses for terminal 15. Put my test light on it. So let's come here and turn it on, and we have command to it. Let's turn it off. So right now there's nothing wrong with our circuit 15. It is able to be turned on by command and it works. So let's try. So that's 15R. Let's just go to circuit 15. Alright, so we got now a fuse there for circuit 15. The first one was 15R. This is now 15. Let's turn it on. And that comes on, off, and it's off. So we don't have a problem with our circuit 15. What we have determined now is the electronic ignition switch is declining to turn on terminal 15. Let's go back in the car. Alright, here's what we know. Terminal 15 is not being commanded on by the ignition switch, but it can be commanded on by the scanner, which means terminal 15 and the front SAM are good. Number two, we know that the key is recognized because the scanner says it's recognized. Number three, we cannot hear the steering lock. So where we are now is steering lock component. If we cannot turn on that steering lock, then whatever we do here is going to be declined. So what we're going to do is, let's go to a wiring diagram, look what the steering lock needs, its powers and grounds, and if it has any data lines, and we're going to scope those data lines and then see what we have. Okay, we're back in WIS. Now we want to find the wiring diagram for the steering lock itself. So let's go to full text search, clear this, expand, check user information and general, make sure all these are checked, advanced search, contained exactly this phrase, and we are going to search for this term. Search aid for all electrical components. Start our search. That's a document. The first one, model 204. The second one is for trucks and buses. Document is open. Close that out. Go back to our search, and now we're going to search for steering lock. There we go. Go into here. Wiring diagram for electronic ignition switch. Okay, let's see what the steering lock needs. First of all, here's the steering lock N265. We can just verify that here. Electronic steering lock control unit. That's this one. It needs a power supply, and look at this. This is terminal 30. So it needs a power supply for terminal 30. We know that terminal 30 is hot all the time. So pin 2 is hot all the time. Pin 1 is a ground. Pin 3 is a data line, and since it's one line, then this is a LIN bus. And then pin 4 is 30Z. So that 30Z goes to N73, and N73 is our electronic ignition switch control unit. And look here, 30Z comes out of N101, and N101 is our front SAM control unit. So the front SAM gives a power supply, hot at all times, pin 30, and then gives another supply, 30Z. But what is this supply? Is it hot or is it cold? What does it need to be? So let's go here. We know that it is coming from the front SAM on 5C to B7 on the ignition switch. So let's go to the front SAM. So let's look for here it is. Front SAM 5C goes to, we are up to 510 because we are 2009, and it is pin 7. So this is our supply line, terminal 30Z. So I'm interested to know, is 30Z hot or not? So 30Z comes here, is controlled by F27. It's also another output here. And then F27 comes all the way here, and there's an input here. So this is the supply for F27. The supply comes into 12S on the SAM, and we are getting this from here up to 509. Let's first check what U119 is. Valid for rear battery. We do not have rear battery, so our option is this one here. Remember, 12S into N101. So let's go now to this. F32 is our front electrical prefuse box. So the prefuse is the box before the fuse box. This is mostly hot at all times. So this is the front SAM 16S. There is terminal 30, comes into 16S. So this is terminal 30. If we go all the way back here, it's this one here, and that's an output. I want to see where the input is for that terminal, but it actually is terminal 30. If it's terminal 30, then that means it's hot at all times. But just in case you didn't know, let me show you how to get it. Here it is. So this is the input for terminal 30, where we're getting our 12S. So our input comes from here. Now U880. Valid for engine 642? No. U739. Valid for 271. So that's our guy. Let's go here. And as you can see, there it is, 21. This comes from G2, which is the alternator, and is connected directly to the starter, also connected directly to battery positive. So all that to say that this terminal 30Z should also be hot at all times. So let's deploy 4 channels of the picoscope. Channel 1, we're going to take terminal 30. Channel 2, terminal 30Z. Channel 3, the ground. And channel 4, this LIN bus. Let's set that up. Our picoscope is set up, and let me quickly show you where we are connected. There's our connector for our steering lock, and those are our 4 channels connected. Let's go to the scope and see what we have. Let's start the scope. And right now, with the key out, look at our blue channel. Now I have some interference here. The electricity on this location is not the best. So whenever you have that, you always want to have a pure waveform. Disconnect your AC line and look what happens to your scope. It cleans up. So this can mess you up a lot if you are in a place where there's a lot of electrical interference. Actually, in general, whenever you're taking captures, avoid taking captures with your AC plugged in. Now, the picoscope is such a fuel guzzler, a battery guzzler. This thing is very battery hungry, and that's because picoscope decided to be clever and put disco lights here. We didn't ask for this. We don't need this. Picoscope, come on, at least give us a way to turn these stupid things off, because whenever this thing is connected, it sucks power out of our laptops. We don't want this. We don't need this. We're not interested in that stuff. So give us the ability at least to turn these off from the scope software. So we have our terminal 30 and terminal 30Z. Oh, and we have a good ground as well on the green, as you can see. So now we take our key, we're going to put it inside, and I want to see a data command out on channel D, which is our data line. I'm going to put it in. There it is. Stop. Let's open this up. And that's a healthy LIN bus. And it appears to me that indeed we are commanding that steering lock to open. Or is that an open command? I'm not sure, but we are commanding it. So let's put the scope on, and I'm going to pull this out, and they should get data again down that line to command it to lock. So pull it out, pause, well, this looks good. Okay, I don't know what the command is, but I know there is command. So currently this is not looking good for the steering lock control module. It appears we have a bad steering lock control module. And remember, if we do not open the steering wheel, this will not authorize terminal 15 to come on. So let me quickly save the open and close captures over there, and then I'm going to compare them with a known good later on, but so far I think that's our problem. But just to be on the safe side, let me take this and save it. I'm interested, is this command to turn on and off the steering valid? If it is, then we have a sticking or a broken motor. But we should hear the relay inside that unit click on and off. I should hear it. It's a very faint. So what am I going to do? I'm going to take a microphone and I'm going to stick it right up there where the steering lock control module is, and we're going to take this capture again, and I want to see whether the microphone will register any sound. If the microphone registers a sound, then we are done. It means this is a valid open and close command, but the motor is damaged. Let's do that. Really exciting, isn't it? All right, I've placed a microphone up there. I just want to show you that. There is the mic. Okay. Now, let's come here and do our setup. That's a very tiny relay that's on that circuit board. It's going to make a very small sound. So what I want to do is to amplify it by making the voltage very low. So I'm only going to do plus minus 100 millivolts, and it's going to capture a lot of noise, but that noise can be filtered out. So let me first start this here. As you can see, that green block, all that is noise. If I zoom in here and zoom in again and again, this is all that hashy noise that's going to be captured. But we can easily filter that out, and we get this. And I can guarantee you that sound is going to be picked up way more than this noise floor. So this is our noise floor for now. We're going to leave it like that, and let's capture it. So we'll take the key out. Ready? So this time I'm going to take the key and I'm just going to slot it in here gently. So what I want to eliminate is this effect. See this? That's just me gently tapping here and the microphone is picking up the sound. So I just want to gently put it in until I see a LIN bus activity and take it back out without making any noise. Watch it. And I pause it. And that definitely is a click of a relay. Now, you may wonder, what are these? Picoscope has got cross-ground interference. This is noise being induced from this voltage here. And I'm going to show you, if I just do that, you'll notice that they correspond to this. Why don't we have it here? Because we are not using the ground shared. That microphone has its own independent positive and negative, and I'm not sharing it with this. So we're not going to get a cross ground on this channel. So anything we get extra is microphone picking up noise. And again, you can see that it doesn't line up with this. See, it's here and here. That relay clicked twice. Now I can barely hear it from here. What I'm going to do is to stuff the camera down there, and I want you to listen to the relay, because if the microphone can pick it up, you'll be able to hear it when I put the phone next to it. So let's do this again. And I will take you in there. And I will put the key in gently. All right, so there it's confirmed 100% that this is a valid open and close command. So that means our steering lock is defective. It's not moving. So we are done. This car needs a steering lock to address this issue. Okay, so I took a mallet and I smacked the steering column here really hard, and now listen to this. Okay, now the steering is unlocked and the ignition is coming on. See that? So the radio is on. Put the radio off. But we still have a no start. We put the key on. So now our terminal 15 is alive. We have an ESP error. I don't care about that. But we do not have starting authorization now. So we don't have a terminal 50, but our steering is unlocked. So I'm going to leave this in there so that we don't lock the steering again. And then I'm going to charge the battery because we are low, and then we're going to try and start this car. Alright, so this is very interesting. The battery was actually very low and the prindle wasn't showing. I've checked in there. I thought somebody had fiddled around with it, but sure enough it's connected. But I just let the battery charge up and then the prindle came back on its own. It was in the key on position, and once I saw this, now the car starts up. All right, so we have authorization. Very nice. All right, just a quick bonus footage to show you what the terminal voltages are supposed to be. Right now, the key is just slotted in the ignition. I don't want to take it off because the steering is unlocked and I don't want it to lock again, and I want to remove it before it locks again. So with it in here, you are meant to have circuit 15C on, only 15C. Then first position, that's accessory position. Terminal 15R is on. So I was wrong saying that 15R is in the run position. No, 15R is accessory position. Then in the run position, next one, transmitter key position 15 is on, and then now circuit 15 is on, and then circuit 50 is only for start authorization. So when I start here, circuit 50 goes on, 15X goes off, and then when you let off, 15X comes back on and 50 goes off. That's it. Just to help somebody there if you need to know what your terminal voltages are. And until next time. Alright, a couple of days later, I went and did some research on what to do about this. I opened this and I found out that the motor is burnt. and the board was okay, but the motor is destroyed. Then I found out that there are two switches here, that there is supposed to be a combination state in which it's supposed to sense lock and unlock after the motor moves. So when the motor moves and the switch locks, and the motor moves again and the switch unlocks, that combination is supposed to go and get processed inside a chip and then send out a LIN signal here to tell the electronic ignition switch we are okay and we can start. That's all this does, and it also locks and unlocks the steering wheel. So Mercedes do not sell this alone, and to get an original motor you can't. The only motors available were from China, and from what I've been reading, the lifespan is between 1 and 1.5 years. That's very low. I did find an option actually of an emulator, and that's this little device here. So this one emulates the PCB in here. All it does is always authorize the EIS. So when the ignition switch sends a signal to this one sends a signal back and says okay. I was going to send it abroad to be programmed, but I found there's just one company locally that does this for me. So they did the emulator. All they needed was the ignition switch and a valid key, and they prepared that for me. So we're back here. I want to put this in the car in place of this. Let's see if it'll work. So there we are, connected. That is the emulator in place of the steering lock, and that's my ignition switch. I'm going to hold it in my shoe there so that I can turn the key. Let's get the key. Okay. You turn it to on position and the dash comes on. Let's start it. And the car starts. Wonderful. So this is solved. All I have to do now is to put the switch back into its place and then find a place to put this one where it's not going to be in the way, and this is done. Of course, the only side effect is no longer do we have steering lock. So if we take the key out, the emulator does the sound of the lock and unlock, but of course we can still turn our steering because I took out the steering lock. No big deal. I've never been a fan of steering locks anyway. Sometimes you need your car towed, and with the steering lock in place it's much harder. Well, that's it. 2009 Mercedes 204, and we've solved the issue for the customer at a reasonable price, and I'm sure he's going to be happy, and I'm happy. This is done successfully. A little bit of a bonus footage here. This is for the geeks out there who love tech stuff. How does this work? One thing that has made me successful in my work is I always spend time playing around with cars that are good in order to recognize cars that are bad. This is the first time for me to be working on this system, so I want to find out how it works. So we have the electronic ignition switch, and we have the steering lock control module. I am interested to know how it works and why are we able to emulate it. So I have a current clamp on our LIN bus, and I have one channel on our LIN bus. We're going to leave the current clamp out for now. I'm going to tell you how we're going to use that. For now, let's just look at the raw voltages coming out of our LIN bus. So now with the key out, we're first going to put the key inside the lock. That is the communication that we have. Okay, so we have this data packet and this data packet over here. Let's continue. Now we're going to turn our key and see what happens. Turn our key to the on position, accessory position, no data communication. Turn the key to the on position, no data communication, and we are on. Now let's start the vehicle. And we have a data communication. And as you can see, this communication precedes the starting. And let's see how long it takes between initial communication to start a command. And that is 131 milliseconds. So that's very fast. You're not going to feel a delay by turning that switch with that kind of speed. Okay, now let's continue. There's no communication when we are in drive. When we turn the steering wheel, no communication. When you accelerate, no communication. So this lives up to its name. It's called a DAS, Drive Authorization System, which means as long as the drive is authorized, that has done its job. This also means that since there is no communication here, I can disconnect my steering lock control module and this should continue. So let's do that. So there we are, disconnected, and we have drive authorization still. I can still drive this car, I can still accelerate, no problem. So should your steering lock control module fail anytime during your drive cycle, you should still be able to drive home. In fact, no errors will be found. Why? It doesn't do anything after that. Once it authorizes drive, it's done. Now let's turn this off, pull this out. Now I want to identify what happens with my communication. How is the communication going between the ignition lock and the steering lock control module? This is where my current clamp comes in. Now the theory is very simple. A LIN bus communication has voltage on that line. First, we need to identify who between the steering lock control module and the ignition switch control module, who is supplying our 12 volts. And as you can see from the scope, when we disconnect this, we have 5 volts on the scope, which means my steering lock control module is the one that's supplying the 12 volt LIN bus voltage here. So if this is providing the voltage, it means when this communicates, it simply communicates by turning that voltage on and off, while this communication is done by pulsing that signal to ground. If we have a 12 volt signal and we pulse it to ground, what should we see? We should see a current flow. So each time my ignition switch is communicating, we should see a current flow on our current clamp, but each time my steering lock control module communicates, we should see no current flow, because all it does is to interrupt that voltage. Okay, so let's put this back. So now we are connected, and let's configure our current clamp. I'm going to come here put it 60 amp current clamp in the 20 amp mode, and I'm going to select the lowest scale, which is plus minus 500 milliamps. I'm going to multiply this by 7, pause it, and then I'm going to employ an aggressive filter, a very aggressive filter. So I'm going to employ a 90 hertz filter on that line. All right. Now, I need to warn you, good use of your current clamp. Whenever you use a current clamp, if you have your current clamp in places where it moves back and forth, it'll affect your readings. This is affected by the Earth's magnetic field. So let me just show you by swinging this. See that? Now if you look at the scope, this can be misconstrued for current flow, but it is not current flow. It is simply your current clamp moving back and forth. Whenever you're using a current clamp, especially when you're dealing with very low current situations, put it in one place, let it stay as still as possible. Don't turn it left, right, up, down, and then once you zero it, leave it there. So we're going to zero our clamp. And it's zeroed. Now we're going to start the scope. And we are ready. So now we take our key. First thing I'm going to do is insert it into the ignition switch. There is our pulsation. Let's observe this. So check this out. This pulse coming from the ignition switch. This is also coming from the ignition switch. This is also coming from the ignition switch. And this is the data response from the steering lock control module. So here we have a call from the ignition switch, response from the steering lock control module. And if you want to know how they look like, zoomed in, that's your call, and that's your response. Now, I'm just saying call and response. I don't know what they are technically called. I don't care. I'm just doing my own evaluation. Okay, now let's continue. We're in the inserted position. Let's go to accessory. No authorization for accessory. Let's go to key on. No authorization for key on. Now let's start it. Pause it. And we have start authorization. This and this are coming from the ignition switch, and this is the response from the steering lock control module. Okay. Let us turn off this. No data activity. No data activity. No data activity. Now let's take off the key. And we have got data activity. Let's pause it. So we've got this section here and this section here. Let's see who is talking. So this is coming from the ignition switch. This is coming from the steering lock control module. Then this large pulse here is coming from the ignition switch. Then there's a shorter pulse here coming from the steering lock control module. So the initiator of communication is always the ignition switch, and the responder is the steering lock control module. And depending on the data response, you have drive authorization or not. That is why we are able to emulate this, because it just needs to know what data packet to send back to your steering lock. I thought that was cool. Really nice system. I'm happy with this diagnosis. A very good one. And my client will be happy. I'm happy because I'm more knowledgeable. And I'm sure you're happy because you're more knowledgeable. Well, until next time, another one for the books. See you.